My name is Edwin Garden. I'm from a firm called FenestraPro, and I'm a developer there. FenestraPro is a company providing software solutions for facade design and glazing specifications, allowing our customers in the architectural and construction fields to optimize energy efficiency and reduce carbon consumption at an early stage in the building design process. The three of us are developers in the firm. Ege handles web development and DevOps. Miroslav and myself started on the .NET development side and have both recently expanded into various aspects of web development. We started our product line off with a web-based app back in 2014 before moving to add-ins in the Revit ecosystem. Our latest release of FenestraPro for Revit is version 8.1, with version 9 on the way. In 2017, we added an online platform, which has also expanded with time, allowing for online project management, data reporting, as well as allowing customers to track building component usage and performance data across projects. Last year, with the introduction of the Forma API, we developed and released the FenestraPro for Forma Extension, which will be the focus of this session. We have two development branches in the Autodesk sphere, the FenestraPro suite of products for Revit, and as of last year, FenestraPro Envelope Analysis, our Forma extension. I'm going to hand over to Miroslav, my colleague, to introduce that to you.
Hi, I'm Miroslav. I'm software developer in FenestraPro, and in today's presentation, I'll be talking about the 3D toolset and the application backend. So at this stage, let's do a quick application walkthrough. So for that reason, I have prepared a video that will be playing in the background, and in the meantime, I'll be talking about the application, so what the application can do and how does it work. But before we do that, let's say a couple of words about the FenestraPro itself. So FenestraPro for Forma Extension enables early stage understanding of the impacts of the building envelope on the internal spaces of the building and how do they relate to the energy, performance, and carbon impacts. So at the very beginning, we need to select the building that we want to analyze. Then after that, we need to define the initial percentage glazing. And at this moment, application is creating analytical openings in the surfaces, and it's recalculating the values. Here in the charts, actually, we can have a closer look at the results for the entire building. Also, we can play with the codes. And now we can go even deeper. So now we are going to the facades level, actually. So we can set the percentage glazing separately for every single facade. If we do that from the sliders, actually, we'll have the single glazing mode. But if we select the glass type, the window type, actually, from our short predefined list, then the application will create multiple glazing. Something similar, actually, like we have in a detailed model in Revit. After this, the results will be recalculated, obviously, and now we have this multi-glazing mode in the selected surfaces. Also, we can have a closer look here. So we are in the charts mode for the selected facade, actually, where we can have a look at the results. And now we are going to the next step, and that's the construction types. From this list, actually, here we can select the construction types for the building envelope, roofs, floors, walls, glazing, and we can also create our own construction type. So here we can provide all the actual values that we need in our calculations. And then after we create it, the construction types list will be automatically regenerated. So we have the new items there in the list. And from here, actually, you can select it and apply it to the building, and the results will be recalculated automatically. Now, this is the new feature, actually. This is the way how we can bring all our work from Forma to Revit. So as we see, all the glazing types, all the windows, openings, and construction types, everything is actually here. Also, obviously, with the building geometry. And we see that actually all of these construction types, they are the same, actually, like the one that we've created in a Forma application. As you see, yeah, they're the same. Okay, so now in the next actually slide, will answer two very important questions. Actually, why did we make this? And like, okay, to answer this question, actually, we need to understand that architectural massing design actually is moving from Revit to Forma. And at this moment, Forma is the best environment for the early staging building envelope analysis. So detailed, like conceptual mass is very important for us because at this moment, buildings are not that complex. So we don't have that unnecessary complexity that we don't need. We don't use it in our calculations, like all of that detailed elements that we have to anyway export in, for example, FenestraPro detailed mode. Here, the building is simple, as I said, and basically the calculations can be much faster. The application is much faster and it's much more reliable. So this is the reason actually why do we move from Revit to Forma. Another question is like, how did we make this? And here we have like four main things, four groups. So we have architecture, toolset, monetization, export. Architecture, so my colleague Ege will tell you more about this, backend, front-end design interaction. 3D toolset, this is my part of work, so this application background, backend, sorry, where actually we're exporting the building and then using 3JS and other 3D tools to actually get the results. Monetization, my colleague Ege will tell you more about this. And at the last piece, Edwin will tell you more about the building exporting from Forma to Revit. Ege, can you please start with the first key? Thank you.
Hi everyone, my name is Ege. So I am the software engineer in FenestraPro, and I'm responsible from front end and the backend side. And now I would like to explain you more details about our seamless integration between Forma and our extension. However, before starting to that, also I would like to quickly mention what is Forma and what is offering exactly. And I think in simple words, like Forma is just a cloud software that offer powerful but still easy to use for conceptual design. Or in other words, you can just set up your project with the real world data and you can just still model your complex 3D design buildings easily, but this time it will be on the web environment. So, and in this environment, we just seen an opportunity actually for facade design and glazing specification, which would ultimately increase the efficiency of the building. So now I would like to talk more about the tech stack that we have used. On the backend side, we mainly use Node.js, Express.js, and MongoDB. So basically on the backend, we mainly run our custom calculation with our logics. And other than this, we are still doing this classical read and write operations for either new or previous calculations. And lastly, interaction between any third parties such as Stripe, which I will mention in the feature slides, will handle via our backend as well. On the front-end side, it's just built with P-React, which is a kind of lighter version of React. It's offer a better load time, and that's why a better user experience. And in the next slides, I will explain you more interaction between Forma and our own extension. So everything is starting with user selection. So first of all, user just selecting the building that wants to analyze, and then we are making sure that that's the main building, or in other words, that this building has a mass. So that's the main building. After that point, using Forma API, we are capturing all the data that we need to run our calculation. We are just sending this data to our backend side. And in here, we are just checking if this building is pre-calculated or not, or in other words, if this user selected this building previously or not. If it is selected, then we are just bring back the previous calculation results to the Forma dashboard. Then they can just update the inputs in order to recalculate, or if it's a completely new building that we didn't analyze yet, then they need to provide us the necessary inputs, such as general window to wall ratio or construction type, and then we are doing a whole calculation from the start. and then sending back all the data that we need to the front-end side. So in this level, so all the data is ready to consume on the front-end level. So we can just update or re-render all the charts, graph, or any kind of outputs that we display in the Forma dashboard or in Forma pages. So, and in the next slides, my teammate Miro will talk about the 3D toolsets.
Let's talk about the 3D toolsets now. So basically, this is about the application backend. So this process between the building exporting from Revit up to the last results, final results that we are providing to user in the application. So here at this stage, actually, we have two levels. You can say two main levels that we are the toolsets that we are using. Basically, first is Forma API to export the building and to get all elements actually that we need in the later calculations, and using 3JS tools and our 3D tools to calculate the items and to provide results. So in this first level, actually, everything is starting from the Revit API, where we are actually getting the building envelope. We are getting the building geometry. That's the 3D tools. And from here, we need to take, as I said, building envelope and also all the levels, details, and everything actually that we need for the later calculations. And then we need to have a closer look at the floor plans. From here, actually, we need to see, okay, what do we have there? What is the outline of the floor plan? What are the exterior walls? What would be the interior walls if, for example, user defines the internal separation lines? Then we need to take all of these points and we need to create the analytical spaces. That's the very first step, what we are doing. Analytical spaces actually are the most important for us because from the spaces, actually, we can extract and calculate everything else that we need. So if we have separation lines, then we are creating multiple spaces per level. So from this stage, actually, we are taking 2D points from this polygons, and we are getting the edges of the spaces. And these 3 points, actually, we are translating later to the 3D points, to the 3D world. From there, we can take that 3D points, extrude it to the next floor, actually, and from there, we can get the ready space geometry. Now, once we have a space, actually, from there, we can get the analytical surfaces. In Forma, actually, in Revit, we've been getting spaces and surfaces directly from the energy model. So here we don't have the energy model, so it's a bit more challenging. Surfaces, actually, we need to say what are the analytical surfaces. Analytical surfaces are the parts of the spaces that are exposed directly to the exterior world, to the exterior, actually, light. So if we have, let's say, nice shape, like rectangular spaces, then that space has, let's say, 4 faces, and 2 of these faces are exposed to the exterior world, and 2 other are going inside the building. We don't analyze that spaces with the interior walls that are surfaces that are going inside the building. We only analyze these 2 surfaces, actually, or these 2 faces that are directly exposed to the exterior light. From there, actually, okay, we will have in that nice shape space, we will assume that we have like 2 analytical surfaces where one face will be one surface. But obviously, if the shape is like more complicated, then we can even compose, like we can even create the surface from more than one face. Everything depends. Now, that's okay, but in some cases, we might have the situation where one face, actually, half of one's face is extruded, is going outside of the building, and another half is inside of the building. So this is a bit more challenging to divide that face and create 2 analytical surfaces, or to not analyze half or part of any 3D face. So to do that and to create the proper analytical surfaces, actually, we need to have a good understanding of the interior and exterior wall. This is why it's very important. So yeah, at this stage, okay, we can imagine that we have analytical elements. We have analytical surfaces and we have analytical spaces. So these surfaces, they need to have host elements. So now we need to provide the host elements, like physical elements for them. The problem here actually is that this is still conceptual massing. We don't have physical walls. We don't have physical roofs. We don't have physical floors. For that reason, actually, we need to create what we are calling virtual elements on our side. So basically, we are creating virtual walls. These objects have the same geometry, like, for example, analytical surface. They still don't have thickness because we don't need that at this stage. So we are taking the surface points and we are taking that geometry and providing it to the host wall. And actually, host wall has the same geometry. We are actually setting a few other things in there. And what's most important, we are setting construction types to that walls. So basically, if you want to calculate performance for that analytical surface, we need to take all the surface elements, and also we need to take that wall actually and take that construction types from that wall to create the result space. Okay, so at this stage we are creating virtual walls like exterior, interior walls, roofs, floors, and so on. So let's imagine at this stage that we have all the elements that we need for the later stage, for the later calculations. Now, this is the stage actually where we are starting using our 3D toolsets and 3JS toolsets, basically. So we are calculating areas, we're calculating distances, dimensions for the spaces, we are calculating volumes, all that items that we need. And basically also what's very important here to define the perimeter depth. So actually, what is the perimeter depth? So this is actually the part of the build of the room, or the entire room actually, that we are taking under consideration, and that is actually exposed directly to the exterior light. So let's imagine we have like a big open space, and that open space is like a deep, let's say 12 meters. So we are assuming that perimeter depth is not bigger than 6 meters. So we will be analyzing only this 6 meters. If my room, let's say, is 3 or 4 meters deep, then my perimeter depth will be that 3 or 4 meters. If it's 7 meters deep, it will be 6 meters, not 7. So basically, that's the perimeter depth. Once we have it, and once we have the surface dimensions, we can get the perimeter zone. That's the area of the perimeter zone that we need and that we use in our calculations. Then at the next stage, we are calculating shading, we're calculating vertical sky angle. That's the calculators, 3D calculators that we have on our side. And then, okay, once I have all of this data, and once I am calculating heat gain, daylighting, and all that kind of things, then I have the final results. But these results at this stage, they're still 0. They are 0 because I don't have the glass. In these elements, actually, they are blocks, just what we are getting from Forma. And we don't have analytical openings. We don't have the glazing. So to have that, actually, to do that, we need to ask user to create that initial percentage glazing from the main slider in the application. So in that case, if user, for example, set my main slider to 50% of percentage glazing, then I take the surface actually, and let's say surface is 120 square meters. That's the area of the surface. Then we need to create the analytical opening that will be 60 square meters with that area. So basically, this is 50% of the glazing for the surface. And then we need to make a hole, like physical hole in that surface. After that, we need to retriangulate everything, and our surface will have that opening. So we create analytical opening element in there. But also after that, that analytical opening also needs to have a host, the same like analytical surface and other analytical elements. So for that reason, we also, again, create the virtual windows. These virtual windows will have the thermal properties, and at that stage, we are taking that thermal properties, we are taking the thermal properties for the host walls, and we calculate the final results for the surfaces. So at this stage, at this moment, we have really valuable results that we can present to the users. Also, in the nearest future, we are planning to create the shading devices there, like in the building. So yeah, that will be also like will give the possibility to the users to create like that devices to set the height of the shading device, to set the depth of the shading devices, and after that they can recalculate the building and they can check what impact does it have on the final results in the dashboard. Now, to give you a better idea for all of this, I have prepared one example just to show you how does it work and how do we use 3JS toolsets. I will show you this is the vertical sky angle calculation. So that will be the example. Okay, what is VSA? Let's start with the what is VSA. In the simplest words, actually, the VSA is the part of the sky that I can see if I stand in front of the window and I look through the window. What is the part of the sky that I actually can see? So I can have obstacles. Let's say I can have surrounding buildings that I have in Forma environment. So that we are exporting from Forma environment. So we have surrounding buildings that, for example, can make that angle lower from below. Also, my visibility can be blocked from above. For example, we can have balconies, we can have shading devices. So all of this is making my vertical sky angle smaller. The maximum value for that angle is 90 degrees, as we see on the second image, actually. And to calculate this, we are using raycasters, and we need to hit the rays, actually. And for that, we are using 3JS toolsets. We are usually hitting 10 rays in the same direction, but with different angle. Here, in this slide, let's have a kind of brief overview for the entire calculation and how do we do that. And after that, I will show you a simple pseudocode that I've prepared for this calculations. In the conceptual mass, actually, vertical sky angles are still, this is still simple. This is still not complex. In the detailed model that we had in Revit, that was much more complex because of the number of the windows, because of the building complexity. So we couldn't use raycasters there because that would really take ages to calculate VSA this way. But here, that's okay. The performance is really good with these raycasters. So yeah, so first of all, we have like, okay, we are extracting the vertices from the surfaces. So that's what we have already at this stage. We have these vertices. Surface center. Surface center will be the same like the bounding box center in the 90% of cases, because still surfaces here are pretty much regular shapes. So we have bounding box center. That's pretty much the same. Then we are creating the raycasters. So that surface center will be start point for the raycaster, and then we know the surface normal, and then that actually normal is the direction where these raycasters should be thrown. The only thing that these raycaster are like they are different basically is the angle. So this is every next ray is going higher and higher, 10 degrees higher. So basically then we are checking if they are hitting any kind of obstacle or not. For that we are using intersects triangle function that we are taking from 3JS, and then we are calculating that angle. If that raycaster hits something, then this angle is going obviously lower. If it doesn't, then it stays on 90 degrees. Taking minimum visibility angle, I will explain this in the next slide with the pseudocode. So let's have a look at the pseudocode right now. We have four really simple functions here, where the main function will be calculate VSA for surface. Here we have two parameters. First one is surface, actually, that we are calculating, and the second one surrounding buildings. Now, these surrounding buildings this is the filtered list. We are not providing all the surrounding buildings here because it can be really a lot of them in the Forma environment. So basically, we are looking first for the candidates that can be our obstacles. Basically, all the surrounding buildings that are behind me, or there are surrounding buildings that are too far away from me, or objects that are too small, we are filtering them out. So we are not providing them here. obviously to have the better performance. So here we are providing only elements that can be potentially my kind of, they can block my visibility from the surface that we are checking. Then surface center, we are calculating surface center, obviously. So that's said before, we are getting that from the bounding box center. And then we are generating actually these raycasters. So we need to calculate, we need to generate 10 raycasters for every surface. As we said before, the start point is actually surface center. Direction is the surface normal. The only thing what we are changing in the vector, actually, that's the Y parameter, where every next raycaster, every next ray is going higher and higher, up to 90 degrees. And we are adding that to the raycasters list that we are providing in the method generate raycasters. Now we are going through every surrounding building. Like we are going for every surrounding building, we are checking these raycasters. So we need to have one loop for surrounding buildings. And inside that loop, we have the loop for the raycasters to check for the surfaces. What is happening basically? So this is the function ray does not intersect, basically. We are checking for the surrounding and we are checking for the raycaster that we are providing to here, one raycaster from that list. So from the surrounding building, actually, we need to get the triangles list. So these triangles list, actually, obviously, this is also filtered triangles list. We are not getting every single triangle from the surrounding building. Obviously, that, let's say, part of the surrounding building that's below my surface cannot really distract my vertical sky angle. So because of that, we are filtering out these triangles. For every single triangle other, we are using the method provided from that actually 3JS is providing to us, and we check if the ray intersects triangles. So if yes, we are double checking and we are checking what is the intersection point. If this intersection point is looking good, they are providing false, so that they are providing it true basically. So it means that it hits something. If it's not like if it's zero, we are providing false. If it's not, we are providing true. Then we have that adding results to our list. So what is this results list? Actually, this is the results for every single surrounding building. And now we are taking the smallest values. Like we said before, if I have 10 surrounding buildings and for one surrounding the vertical sky angle is 90 degrees, for another is 80, then 70, then 50, I'm taking that minimum value, and that minimum value will be my real vertical sky angle. So it means it will be 50 for the surfaces that we are checking. Yeah, that's it for the vertical sky angles. Now let's go back to my colleague Ege and monetization. Thank you.
Thank you, Miro. So now I will talk more about monetization and how we implement it actually, and how you can implement it into your application as well. And the first part is the user management. So it's not different than the usual user management. So user can just need to put their email and password, and with these credentials, the backend is gonna approve their the backend is going to check that these credentials are correct, and then JWT token will be created on the API side. And later we are gonna use this JWT token for secure API connection and also personalize the data for tracking and login purposes. And lastly, we can just offer a certain functionalities based on the user state or the subscription level using this token as well. And after that point, you just need a kind of online payment processor. And the first option that comes to our mind was Stripe actually, since it's offering a comprehensive payment option internationally, and also your company can easily manage the financial operations as well. And when it comes to integration between Stripe and your system, it should be relatively simple. Like Stripe has really amazing documentation that you can use according to your specific business needs. And in our case, we decided to use Stripe embedded view actually, since in this way user can subscribe into our extension without leaving our extension or going through another tab or another website. And in the next page, I just create a kind of workflow for you to explain better. So yeah, in here, first of all, you need to register the Stripe, and when you register, you are gonna get two keys, one public and one private. So you are gonna use this public key for the front end side and private key on your backends with your communication with the Stripe APIs. So on the Forma extension, basically we are just showing a kind of table and features that you are gonna use if you are gonna subscribe. And in here, when you hit to subscribe, then we are sending an API request to the Stripe site using checkout session. And from this API call, we are going to receive a client secret. And we are just going to hand over that secret to the front-end side. And using that client secret and public Stripe key, then we can generate this embedded payment screen on the front-end side. On this payment screen, actually, everything is pretty much automated. So if something is failed because of the cards, it's gonna give all the necessary responses that you need. But if the payment is successful, then it's gonna trigger an onComplete method. So, and this is the function that you should create your custom workflow. So for us, it was pretty straightforward. So we are just checking the Stripe side again using user and subscription APIs. And we are just making sure that everything is correct about the user. There is no mistake. And then we just return into our API side. We just update the necessary records in our sites. And then we let the front end know, okay, everything is completed. Then after that moment, user can use all the premium features that we are offering in our extension. And on the next page, actually, I would like to talk quickly about the features that we offer for basic user, for registered user, and for subscribed user. So in this page, you can see three kind of tier that we offer right now: basic, registered, and premium. So basic version is free, and there is no need to any kind of login or registration. So in order to use our extension, you don't need to register. You can use it. And the second tier is the registered version. Still, it's free. You just need to register yourself and you can log in. And the only difference between basic and registered version is the save option and create and manage your code. So basically, in another word, let's imagine yesterday you just select a building. You just provide us all the inputs that we need to run your calculation. But tomorrow, if you click the same building again, we are not gonna bring back the old results. So you need to start from scratch. But if you are just registered and logged in, then when you click today, first of all, we are just gonna bring you all the previous results and the previous input that you have selected before, so you can continue where you have left. So, however, on the premium, which is a kind of new tier to us after the Stripe integration, so we are trying to offer you more comprehensive and more useful tools, such as like generating Forma board inside, or distributing your glazing per facade or per surface, applying a window geometry to your model, shading devices, and more. So, and this is pretty much it. And in the next slide, my teammate Edwin will talk more about Forma to Revit workflow.
The last piece of the puzzle is to get the model from Forma's more conceptual environment into Revit's detailed environment. We know that a Forma to Revit add-in already exists, but as we're expanding on the geometric information, the geometric model information represented in Forma, we needed to create an add-in that would include information such as the percentage glazing for a surface, the type and number of windows, the performance of the external envelope, and so on. So we start on the Forma side, where we need to export the model data structure, including a user tag, project information, geometry, and the building envelope information. We then save the model to MongoDB for retrieval from the Revit add-in. In Revit, the user signs in and is shown a list of the exported projects. And once a project is selected, we open up a template file via the API, where we have set up several families that can be mapped to the properties that you've selected in Forma. Once that is done, we open up a new Revit detailed model based on the template when we import the geometry. We have to include right-hand rule conversion to get from 3JS coordinate system to Revit coordinate system. And from there, we create the building. We use floors, walls, roofs, and windows, and we set the family symbols and types to match what was selected in Forma. We explored various strategies to get the external building fabric specifications from Forma to Revit. And one option was to map walls, roofs, and floors to Revit schematic types. These schematic types have been available to Revit users via the advanced energy settings, and that's the window you see here, but only by the API since Revit 2025. So using the new API, we're now able to assign the schematic type and set the override so that the schematic type will be used when creating an energy model in Revit. The API workflow is then to get the full MEP building construction object. It's top there, the first line. From there, we can pull the constructions for each category. And in this case, we use get constructions of type exterior wall. We're then able to get a construction by matching its ID string. And that's, in this case, it's con-w101. Then we can set building construction of that category with the construction we have retrieved before. For the energy model to use the selected schematic type, we need to override that category, which we can do with the set building construction override method, which takes the construction category and a Boolean value. So that covers the current state of the Forma and Revit workflow, and we move on to the future of our Forma extension. In the near, mid to future roadmap, we'll be adding shading devices to building facades and the ability to evaluate the performance on a per surface basis. Another of our goals is to improve extension performance so that we support large and complex models. Forma is also planning to support a more detailed modeling environment, parametric families and other detailed elements. And we aim to integrate our extension with those as they are rolled out. Lastly, we aim to add functionality to Forma Connect, which is the Forma to Revit workflow, specifically around integrating and supporting BIM manager workflows. So to recap, we've taken you through the front-end and back-end workings of our Forma extension. We've shown you how we've used the Forma API and 3JS to overlay our business model logic over Forma's mass forms. We've explained how we introduced a tiered paid subscription with a third-party payment service. And lastly, we demonstrated a Forma to Revit workflow using changes to both the Forma and Revit APIs. Hopefully, we've inspired you to investigate the Forma API to see how you can add value for your customers. Thank you very much.